So I've encountered this problem that wants me to find all values of k for which this function, cos of kt, satisfies this second-order differential equation. There's something really important to note here. This dE is homogeneous. Homogeneous means that there's an equals 0 on the right rather than an equals 1 or an equals 2. Okay? And so what that means is the 0 function is always a solution. And we actually don't want that to count as a solution. It kind of is the silly solution. We don't really care about it. And it definitely works, can you tell? Because all the derivatives are 0. So you're going to get 0 minus 6 times 0 equals 0. We don't want that to count. And what that means for this problem is that plus or minus pi over 2, plus or minus 3 pi over 2, all of the k's that you could plug in here to get exactly 0, they're going to be excluded from the solution set. So, okay. This is a second-order dE, which means I need a second derivative. Here's my function, here's my first derivative, and here's my second derivative. That's my scratch work off to the side. I'm going to use my y and my y prime prime expressions here, and I'm going to substitute them into the equation. I get minus k squared cos kt minus 6 times cos kt is equal to 0. And I need to simplify this and factor out a cos kt, and so the other factor is going to be negative k squared minus 6 is equal to 0. So here's the thing, this splits, right? Anytime you have two factors multiplied equal to 0, you can split them. You get cos kt equals 0 and negative k squared minus 6 equals 0. Now these don't count, right? We already discussed why. If any k that's the solution to this little equation over here is going to create the 0 function, and we don't want that. So ignore that one entirely. Now on the right, you have negative k squared minus 6 is equal to 0. And you have k squared equals negative 6, well, that also results in no solutions. So, in fact, no k's exist at all.